Let us find all the positive integer x, y, z that satisfy the equation 4 to the power x plus 4 to the power y plus 4 to the power z equal to 1092. We assume that x is greater than or equal to y and y is greater than or equal to z. This is just a simple assumption to make our work easier. It may happen that y is equal to z or y is not equal to z. So let's start with the simplest case, case 1, y equal to z. Then this equation can be written as 4 to the power x plus 2 into 4 to the power y equal to 1092. As x is greater than or equal to y, we can take 4 to the power y common and we can write this expression as 4 to the power x minus y plus 2. Let's factorize 1092. 1092, that's equal to 2 into 546, that's equal to 2 into 273, and that's equal to 3 into 91, and that's equal to 7 into 13. So this can be written as 4 into 3 into 7 into 13. Now further, it may happen that y is equal to x or y is not equal to x. If y is equal to x, then this quantity is 1 and 1 plus 2 is 3. But we don't have 7 as a factor in the left hand side and we have 7 as a factor in the right hand side. Therefore, y equal to x is not possible. If x equal to y, comma, 7 is not a factor of LHS, left hand side, but 7 is a factor, so not possible. We have assumed that x is bigger than or equal to y. If it is not equal, then it has to be bigger. So x is strictly greater than y. So this expression can be written as 4 to the power y. When x is strictly bigger than y, you can take 2 common from this expression. So let's take 2 common. And you are left out with 4 to the power x minus y by 2 plus 1 equal to 4 into 3 into 7 into 13. You see that if y were 0, then this quantity is odd, and this is even. If y were 0, okay, we cannot take y 0 because we are having positive integer, but y were at least 1, so 4 into 2 is 8. 8 is a factor of left hand side, but not right hand side. Since 8 is a factor of left hand side, but not right hand side, comma, a contradiction. Therefore, we are bound to say that x is not, what we did? We did x equal to y, then 7 is not a factor. So that's not possible. If x is not equal to y, then also we found that it is not possible. Therefore, we are done with case 1. Case 1 is simply not possible. Well, we have started with something that is not possible at all. Let's move to case 2 then. If y is not equal to z, but we are given y is greater than or equal to z, so we can say y is greater than z. So let's write the given equation once again. 4 to the power x plus 4 to the power y plus 4 to the power z equal to 1092. So 4 to the power y and 4 to the power z are not equal. Let's take 4 to the power z common from this expression. 4 to the power x minus z plus 4 to the power y minus z plus 1 equal to 1092. We have factored 1092 as 4 into 3 into 7 into 13. Now as x is greater than or equal to y and y is strictly greater than z, this quantity is even and so does this. This is even. Even plus 1 is odd, so this quantity is odd. Now we have 4 to the power z equal to 4 into something, this is odd, equal to 4 into 3 into 7 into 13. So only choice is z equal to 1. If z equal to 1, then we have 4 to the power x minus z plus 4 to the power y minus z plus 1 equal to 3 into 7 into 13. 3 into 7 is 21 and 21 into 13 is 273. Yes. So 4 to the power x minus z plus 4 to the power y minus z equal to 273 minus 1. So 4 to the power x minus z plus 4 to the power y minus z equal to 272. Let's factorize 272. It's divisible by 4. 4 into 6, 24, 8, 68. Then 234, then 217. So we can write this expression as 4 to the power x minus z plus 4 to the power y minus z equal to 4 square into 17. Again we take 4 to the power, we already have z equal to 1, so this can be written as 4 to the power x minus 1 plus 4 to the power y minus 1 equal to 4 square into 17. As x is greater than y and y is strictly greater than z, so we can write this expression is, we can take 4 to the power y minus 1 common and 4 to the power x minus y plus 1 equal to 4 square into 17. But x is strictly x may be equal to y. If x were equal to y, then this is just 2, and that cannot be true, because 2 into 4 to the power y minus 1 cannot be equal to 4 square into 17, because you need 17 as a factor in the left hand side as well. So x is strictly greater than y, clearly. Since 17 is a factor, x is strictly greater than y. Therefore, 4 to the power x minus y plus 1 is odd. Now, if it is odd, then we must have 4 to the power y minus 1 equal to 4 square. So, y minus 1 equal to 2. So, y equal to 3. Now, let's write value of y equal to 3 here. So, we will obtain 4 to the power x minus y plus 1 equal to 17. That gives us 4 to the power x minus y equal to 16, and 16 equal to 4 square, and y is 3, so x minus 3 equal to 2, so x equal to 5. So finally we have solution x equal to 5, y equal to 3, and z equal to 1. That's it. Of course, under assumption that x is greater than or equal to y, y is greater than or equal to z, you can rearrange and get other combination as well.